All right. So last time we completed the topic or the chapter of dynamics, where we talked about forces and all of that, accelerations and everything. The today will try to start this new chapter and try to finish it as well. Mass, weight, and density. Right. Is there before we do that? Is there any question from the last lecture from anyone?
I
Uh,
have no questions.
No,
no
sir.
questions. All right. By the way, I came to know that some people had this problem that some of the things that we did in last lecture and we were doing, um, they thought that they were too advanced or something like that. Uh, Maybe it was that you people have not attended the previous classes, because my goal is to, in fact, most of this class, I get these comments that we are spending too much time on some things, and sometimes they're pretty obvious things like using the trigonometry in understanding forces and resolving the components of forces. We have already covered that in detail in the first chapter on physical quantities, and that topic, that chapter is also, you can find it, it's available on our website, on the website of Mega Lecture. It's also available, the lecture is available on YouTube as well. So far it is available, so you can go through those chapters from there and then come back to these lectures as well. So that would make things really clear, because my goal is to make things very clear. That's at least what I try to do. I try to make things as clear that as I can. All right. So with that, let's start the next chapter, which is of this mass, weight, and density. Um, we'll start by the most simplest thing, which is mass, the concept of mass. All right. So what do you people think? What is mass? How can I define this quantity that's called mass for anything, for any substance in general? How can I define mass? Any volunteer?
It's a physical quantity uh, of bodies, of
All right.
objects.
You're saying resistive quantity?
It is the amount of I think quantity of quantity
You
of
can
matter.
say matter, right?
Yeah,
Yeah.
quantity of
So,
matter.
so
Amount.
these are some things. These are some things that you can say. One of the thing that you can say is amount of stuff or amount of matter in a body, right? And this definition is good enough for our purposes, that we can consider that we can define a mass uh, by simply saying that it's the amount of stuff or matter contained inside a body. But when you think deeply about it, then you'll run into problems and all of that. Newton himself defined mass as just a measure of something, right? And a measure of Newton defined mass as a measure of something that is called inertia, right? Inertia. And this thing, it's a fundamental property of all the matter in the universe, right? It's a fundamental property of all matter in universe. And we're going to talk about this thing, inertia, in detail as well. But so far, this much is enough. Inertia is really just, you can think of it as a resistance that a body offers to change in its velocity, right? Or you can say the resistance that it offers to any force that is applied to a body. So for example, if I have a body like this, the more massive it is, you will see that it doesn't I apply some force to this body. Suppose it is this much. Then it will change its speed. We have already learned that the force will cause it to accelerate. Suppose if the body is this much, so you can imagine that maybe it's a block of iron, so this one would be heavier than the smaller one, and you apply the same force to this one. Which one would be heavier? Which one would be more difficult to accelerate? What do you
The
think?
one
The
with
heavier one.
the one with the more density.
The one with the more density, or the one with the more mass, right?
Yes.
So then this one would be more difficult to accelerate. Now that simple statement just defines inertia, right? So the more massive something is, the more difficult it is to change its speed, right? All right.
Yes.
Okay, great. Now, so mass is a physical quantity. It's a physical quantity, and every physical quantity in physics can be measured. And to measure mass, we need a unit, and that unit for mass is kilograms, right? The unit for mass is kilograms. This is the SI unit. Kilo, we know kilo is just a prefix. We have understood that from physical quantities, and the unit is grams. Combine these prefix and units makes a SI unit for mass, which is kilograms. All right. So can you tell me what would then the mass depend on? Any hints? So we'll list some quantities on what mass of an object could depend on.
I think it's don't
Think
really
in
know.
terms of, yeah, you can think in
Yeah.
terms of its definition, right? Definition is it's the amount of matter in a body. So you can think in terms of that.
The matter in the body. It depends on the matter in the body.
The
It
denser it
depends on
is,
how, yeah,
if it's dense, then there will be more
yeah,
matter
yeah,
in a small space, so
exactly, right? Yeah,
it'll have
so
more mass.
that that's very right, right? That's very right. So it then essentially you can say that it depends on the you could say something like the amount of atoms that combine together to make this object, or you can say the composition of all these atoms that are going to combine together to make up this object, right? So then you can say that it depends on the, let's use this word, composition of atoms, right? And this includes density. This means density as well. This means what do you say that? This means the amount of matter. How much? The more the matter is in the body, the more the mass is. And how can I get more matter? By increasing the number of atoms, right? And how can I make something more dense? If this is my object, and if I contain in this volume, I add more and more and more of atoms, then it would make this object more and more and more dense, right? Is that clear?
Yeah.
Yes, clear.
All right. So in fact, this simple statement contains all of these things, that the density, the number of atoms, the number of molecules, and so on, right? So these things are what a mass of an object could depend on. All right, so this is mass, right? This is the concept of mass, more or less. What is one other thing that people often confuse with mass? Anyone?
Wait.
Weight, exactly, right? So that's something that we're going to come to words now. Before we do that, is there any confusion in the idea of mass and
No.
its relation to the inertia of the system?
Sir, what's the meaning of inertia?
Blah.
Oh, all right. So I will talk about it in a bit. but I'm going to give you an example which will make things completely clear of what inertia is. And it's this example where I gave you this thing that suppose you have a block of, suppose it's an iron block, and this is a small block. And if I'm saying it's a block of iron, that means the density is constant for both of these blocks. It would be the same as the density of iron. And if this is small block, then this would have a smaller mass. And this is a big block, it would have a bigger mass, larger mass. What do you think would be more difficult to move if I apply same force to these blocks? Which one would be more difficult to move?
The bigger block.
The bigger block, the one which has more mass, right? So
Yes.
inertia is really a property that you can say, think of it as the resistance that a body of matter can offer to change its speed, change the speed. So the more mass there is, the more difficult it is to move an object, and that's inertia, right? It's a fundamental property of all the matter in the universe, right? In fact, inertia is how you define this quantity mass. Newton never talked about mass, really. He talked about inertia. And mass is just a measure of inertia, according to Newton. And that's the proper way to think about mass, really, right? And then this measure of inertia is given a name, which is mass. So whenever you say mass, you should think of how much inertia there is in the system. The more inertia there is, that means the more difficult it is to move the body, right? That makes things clear slightly?
Yes.
Yes, sir.
Okay, amazing. So any other question from mass?
No.
All right, okay. So we'll move on to the next topic of weight, and let's discuss the concept of weight now.
So I had a question.
Yeah, sure. Go ahead.
Will the densest element, the densest substance will be the heaviest substance?
The more the dense the substance is, the more heavier it can be. Yes, you're right. But that depends on the volume that the amount of matter is occupying as well, right? So you have to think in terms of volume as well. So we are going to talk about density as well in a bit. As soon as we're done with weight, we're going to move on to density, and then you'll get your answer in a much more detailed thing, right?
Yes, sir.
Okay. All right. Okay. So because I'm just telling you this thing right now because if you were there in the first class or you have watched those videos, we talked about density, which is represented with the symbol rho, and it's just mass over volume, or the ratio of how much mass is contained inside a volume, right? That's what density is. So when you think about it that way, if you keep the volume constant, then the more denser something is, the more massive it can be if the volume of the object is the same, right? So we'll talk about that in a bit, but I hope that I was able to clear your thing. All right. Okay. So weight. Any idea what weight is?
It is mass times gravity. Mass times gravity.
Yeah, exactly, right?
It's a
so you can
force.
say
Sir?
you can. Yeah.
You can
Sorry?
say like the weight is different on every planet, depending on the
Yes.
gravity.
Exactly,
Yes.
exactly, right? So that's very true. That's very true, right? So I can generalize this as a conceptual thing by saying that weight is just a result of gravity, right? It is the result of how gravity would affect something, right? Or how gravity would affect a mass. That's weight. So that's how mass and weight are different, right? So weight is there because mass already exists, right? And how does that mass is going to be affected by gravity is weight, right? So I can say that weight is simply a resultant of the effect of gravity on some mass. All right. So what that means is, suppose that this is the surface of the, I'm going to say that this is the surface of the Earth, and this is the surface of the moon. We know that the acceleration due to gravity on Earth is something, and then there is acceleration due to gravity on moon. And we know clearly that on Earth it is greater than that of moon. We have talked about these things in kinematics. We have also slightly talked about these things in physical quantities. So, but if there is anyone, if you have any question, if there is something that you think that you've never heard of, feel free to always stop me and then ask me that to explain these terms that I might be using, right? But I try my best to, if I'm introducing something or if I'm using a name of something, I try my best so that I have already defined that thing for you. So if there are new students joining recently, you can do two things. You can either watch all the previous lectures, which would be available on YouTube or on the site megalecture.com, or you can just stop me, literally stop me anywhere in between the lecture and ask me if you do not understand something, right? I don't mind that. I'm not a teacher who would say, who would mind this thing that you're stopping me while I'm delivering a lecture. I in fact encourage questions. I've said this in the first demo lecture as well. I encourage questions. I really like when you people ask questions. My goal here is also to promote thinking, right, in young minds. So feel free to always ask your questions. Never hesitate. I don't want you hesitating at all with questions. Anyways, so with that, is there any question regarding these acceleration due to gravities in anyone's mind?
No questions. I understand.
All right. So is that
Yes,
clear
sir.
for everyone? Do you have this idea that acceleration due to gravity on Earth is more than on Moon? You would kind of know if you know what the acceleration due to gravity is, right? So it depends on the mass of the planet. The more massive the planet is, the more acceleration due to gravity is there. And acceleration due to gravity is just the thing that if I have an object, this object is going to, suppose it's a ball, it's going to experience an acceleration towards the center of the planet, right? And so on both the planets, it would experience some acceleration. And that just means if this thing is greater than this thing, then this object will fall towards the Earth, increasing its speed more compared to this object. This object's speed would increase slightly slowly compared to this one. And that's why you would understand that why this object appears to slightly float on the moon while this object falls in our conception, it falls directly towards the center of the Earth. Is that idea clear for everyone?
Sir,
Yeah.
actually, I have a question.
Yeah, sure. Go ahead. Can you please come more closer to the mic so that I can hear you properly?
Sir, can you hear me better?
I can hear you, but it's quite low. Let me turn off the fan over here. All right. Okay, go ahead.
Okay. So, space is relative, right? So, could we say just as you said that the object will be falling towards the center of the Earth, could we say that the Earth is falling to the center of the object?
Well, you cannot really say that because you would have to see how the Earth is moving, right? And now this would kind of take us slightly off topic, but I'll just give you this thing. I'll just tell you this thing, that in our solar system, the model of solar system that you're familiar with could be that you have a sun and then you have planets orbiting the sun like this. and then you might have another one which is orbiting the sun like this, and so on, right? But this model is not really the correct model. uh, the sun is not stationary, it's not sitting still. Everything in the universe is dynamic, it's moving, it's doing something. It's not boring. Our universe is not boring. It's very interesting. In fact, the sun is also moving, and that means the planets would also be moving because they're falling into that orbit continuously towards the sun. And so these planets are also moving. So if these planets are moving, then you can slightly, you can say this thing, that if I have an object and it falls towards the planet, I can also go the other way around and I can say that the planet is falling towards the object. But that completely, as you said, that completely depends on the observer, meaning you, right? How you think of the situation, how you look at the situation. The situation could be different for two different people. But we are not going to get into that right now. So because that would be very off topic, and that would be slightly more, a lot advanced things, and I don't want to get into those right now. By the way, if you want to, if you're interested in all of these things, we can arrange a class on maybe a weekend or Saturday. We can talk about these interesting things. I wouldn't mind that. I would enjoy that as well. You can post your ideas in the group, and we can talk about those topics in that extra class. But that class has to be separate from this one, right? So that we have to cover the topics as well. In fact, I would really like that if any one of you think that that's a good idea, right? But anyways, so shall I proceed forward?
Yes.
All right. Okay, great. So we're talking about weight, right? Now, the weight is, again, it's just a result of how gravity would affect any mass. So on Earth, because gravity is stronger compared to the moon, you can think of this GE and GM as the strength of gravity. And on Earth, it's stronger. So the weight of any object on Earth would be more compared to the weight of any object on the moon, while the mass remains the same. And you can write down an equation for this as W, which is weight and mass times the acceleration due to gravity, right? So more the acceleration due to gravity for a planet is, the more the weight is, right?
Yes.
And the mass remains constant. So you can write it as a proportionality as this thing. So this just means that weight is directly proportional to the acceleration due to gravity, while mass is just the constant of that proportionality. So mass remains constant, right? Now that's weight. And we now also understand that the weight is going to change or vary, the value for weight on different planets depending upon the value of gravity on those planets. So is this clear for everyone?
Yes.
Clear.
It's clear. All right, great. So now let's slightly compare mass and weight, right? So now let's just quickly compare mass and weight. All right. So again, the first thing is very simple, that let me compare them using this table kind of thing, right? All right. Okay. So first thing is, mass is the amount of matter, right? Amount of matter, or you can say it's the measure of inertia. While weight is the result of gravity on matter. Result of gravity on matter, or on, you can say on mass, right? On mass. So clearly you can see that if I had not defined mass, I could have not talked about weight, because I'm using the word mass in the definition of weight, right? So mass is completely different, but how it is affected by gravity is weight. So that's the difference between the two. So I hope that now you'll never be confused between these two things, mass and weight. The other
Sir,
thing, yeah,
for mass number 1, what did you write?
amount, the AMT, it's just an abbreviation I've invented to shorten things. So,
Oh,
amount of matter, right? Okay, I apologize for that. I think I'll write the whole thing. I'll just write amount of matter.
no, sir. AMT is fine.
Okay, all right. Okay, so the second thing is think in terms of scalar and vectors now. What do you think? Would mass be a scalar or would it be a vector? We have
It's
talked
a
about
scalar.
scalar and vectors as well,
Scalar, I think.
right?
Scalar.
Right. So
A
scalar,
vector, I think.
okay, I'll just quickly give a small and a very basic
Scalar.
definition of a scalar and vector. Scalar is just a number. You need only a number to specify scalar, and a vector is something that you need a number and you have to tell in which direction this quantity is, because changing the direction would change the quantity as well. So that's scalar and
Yes.
vector. So yeah,
Can
so
I-
mass is
mass is scalar and weight is a vector, because weight is going downwards towards the earth. Is that right?
right. So weight is always centered towards the earth. It's like a force. It's in fact, it is a force, and it would matter if I were to change the direction of that arrow. That would change how the force would act on a system. As we have already talked about this thing, if I have this block and I apply a force from here, then the block would move here. Something happens. But if I apply a force over here, then the block would move in the other direction, in the direction of that force. So the physics happening is different. That means force is a vector. Direction matters, right? In force, in a vector quantity. All right, so that's why mass would be a scalar, because it doesn't matter. There is no concept of direction in the amount of matter, right? It's just a number. It's just how much of matter is there in this body, how much of the atoms are there. It wouldn't matter if the atoms were moving in this direction or that direction, as long as they're sitting in, as long as they're in that volume or in that body, then there is mass, right? And you just need some number to quantify mass. That's why it's scalar. While weight, as we have talked about, is a vector quantity. All right. So we'll not go into any more further contrasts between the two. I think this is enough. You can already figure out that if weight is like a force, then the units for weight are newtons, while the units for mass would be, obviously, we have talked about it, kilograms, right? Okay, so with that, let's move forward. The goal was to complete this chapter today, but I think that might not be possible. We have talked about gravitational field and gravitational field strength as well in the topic of kinematics, right? We have talked about the acceleration due to gravity as well over there, and so on. So would you like me to go through those things again? Or if you forgot it, you can go back to those lectures and revise those things. Just let me know quickly. Should I
Sir,
go through
we
it
can go
again?
back.
Okay. If you can go back, if everyone agrees with that, then we can move on to the topic of density, right?
Move on to the topic of density.
I'll move on to the topic of density. Right. Okay. So if anyone if anyone even at this point says that no, I want you to go through gravitational field, so I'll go through gravitational field. So but you have to speak up, right? So to speak up. All right. So density, we have also kind of talked about density before. It's very interesting thing. Density is simply defined as how much mass or how much of atoms occupy a particular volume. So for example, I have this volume, I've bounded it by this square, and suppose I put in some number of atoms in this volume, right? Suppose these are the atoms that I've put in. Pretend that they are of equal size, and this is the amount of matter that I have in this much volume. And again, suppose that this is the same volume. The volume did not change. This is volume V, this is volume V, and now I have a lot more atoms in it, right? Suppose I have these many atoms.
The
Which
density would
object?
increase.
Yeah, so which, exactly, right? So my question was that which object do you think would be more dense
The
compared
lower
to
one.
the other one? The lower one would be more dense, right? According to the definition of density. The very usual definition that you would learn about density is that it is defined, or let me first say that the symbol for density is rho, and it is defined as mass per unit volume. Just telling you that is not really enough. It is not doing justice to your understanding. You should understand it in terms of pictures as well, right? So this is the picture that you can think of while you're talking about density. So the more the amount of stuff there is in some body, if that body has the same volume, then the what do you call that? Then it would be more dense compared to the other one, right? So that's density.
Yes.
All right. So, well, that's more or less, that's density. Now we can talk about some of the interesting consequences of density as well. First of all, let me just tell you that this is mass and this is volume. I'm sure that you already know that, but for the sake of preparing notes, we'll have this. And then we can also write down the units in which I can measure this quantity called density, because the units for mass are kilograms and the units for volume is meters cube, because volume is again a three-dimensional object, you can say. And so it's meters times meters times meters, and it's meters cube. Anyways, this would make the units for density, the SI units for density, as kilograms per meters cube. All right, now let's talk about an interesting thing. You know, if you have an ocean of water, right? And I have a ship that sails in this. You'll have to completely ignore the drawing. But suppose you have a ship and suppose it has so many more containers on the ship as well. There are so many containers sitting on this ship, which would make the ship really, really heavy, right? So the ship is really, really heavy now. You know that you have seen this thing, that the ship would be floating. The ship would be floating on the surface of the water. It would not sink, even though
Yes.
the ship is so heavy, right? It's really heavy, right? I mean, you
Sir,
can
can I
imagine.
say?
Yeah.
Sir, the upthrust of the water changes the weight of the ship so it can float on the water.
It's called buoyancy.
Nice. So some of you are already aware of these more advanced concepts. In terms of, so that you can describe that also in terms of density, right? That's a more advanced, or you can say modern way of talking about this thing, a very simple explanation in terms of density could be what? If you think in terms of density. So there are two objects. Suppose that the ship is made up of iron, and everything on the ship is made up of iron. And this is water, right? This is water. So in terms of density, can you explain in very simple terms why would this ship not sink inside this water?
Because its
The
density is lesser than the density of the water. The ship's density is lesser than the density of the water. It has
Exactly, right?
got
So
empty air compartments.
exactly, that's very true, right? So if I were to compute the density of this ship, and for our sake of simplicity, we'll suppose that everything on the ship is made up of iron, then I just need the density of iron, and I can find it from the literature or whatever. I can find the average density of the iron or the ship. Suppose it is 360 kilograms per meter cube. It's approximately equal to this, right? It could be approximately equal to this, the density of the ship, really. So I'll just write ship over here. And the density of water is what? You can again take this from literature, or you can compute it. But the
1,000
density of the water is, yeah, it's
1,000
approximately
liters per
1,000.
meter cube.
Exactly, right? Okay, so what does this mean? This means that if I have this ship, there 360 kilograms of stuff sits in 1 meter cube of volume. So if I again come back to this diagram, this is ship, and this I need the same size of box. So what I'll do is I'll just copy paste this thing. So this box is exactly of the same size. So consider that this box make up a volume of 1 meter cube, right? So this is 1 meter cube, 1 meter cube. And this is for water. What this means physically or conceptually, what these numbers mean is that if I have 1 meter cube for a ship, then there would be 360